Okay, greetings everyone. So this is week one's interactive session, and this will be helpful for you in solving your homework one. So what we will be doing in this session is discussing few questions which are similar to what you will be solving in the assignments. So these questions, the discussions I hope will help you in understanding the course material better, and it will be helpful for you in the control systems application. So the first question we will be discussing is this: a system whose governing equation is y equals to t into u of t. So the question here is this system linear and is this system time varying? So uh, let us see. So the given system is governed by this equation: y of t equals to t of u into t. So the first thing we can look at here is this term, the coefficient of u, which is t. So uh, so since this term t is dependent, is indeed the time, the response y of t will be different for different time. For example, let's take t1 is equals to 1 and t2 is equal to 2. So if we give the same input, u, say u1, so our y1 of t will end up being u1 and our y2 of t will be 2 into u1. So this argument implies that the output of the system depends on the time. Explicitly, that means if we give the same input, if the same input is given at different time, the response of the system would be different. This indeed uh, can let us say that y of t is equals to t into u of t is time varying. So now coming to the second portion, is this system y of t equals to t into u of t linear? So a linear system will follow the principle of superposition. That means if uh, when is a system linear? If it satisfies these criteria. So say that for the input u1 of t, we get output y1 of t, and for say u2 of t, if the output of the system is y2 of t. Given this, if the system's output, if we give the system the input of say u1 of t plus u2 of t, This would result into the system's output as y1 of t and y1 of t plus y2 of t. So this is condition A. This is our prerequisite, and our condition B is, say if we give the input of A into u1 of t, where A is some constant, and the output of system becomes A into y1 of t, when the conditions A and B are both true, then the system is linear. So let us check for our system. We have let's see if we give so these both conditions we can combine as A into u1 of t plus B into u2 of t as an input. So let's give this an input and see what the output comes. So y of t is equals to t in bracket A into u1 of t plus B into u2 of t is equals to t into A into u1 of b u1 of t plus t into b into u2 of t. So if we split these terms, it will be A in bracket t into u1 of t plus B in bracket t into u2 of t. Now if we look at this term and this term in bracket, it is essentially, so if we look at these two terms in the bracket, it is essentially A into y1 of t plus B into y2 of t. So y of t is equals to A into y1 of t plus B into y2 of t implies the system is linear. So shall we wait for questions now, or shall we go for questions at after completing the assignment?
Sir, after completing the assignment, that's better, I think so.
All right. So
Yeah, my audible, sir.
yes, I can hear you. Okay, so we will continue on to next question. Our first question was we have been given a system and we want to figure out whether the system is linear and whether the system is time varying. So if we give the same input at two different times, we can see that the output of the system is different. That means it is time dependent, and the linear system essentially follows the principle of superposition. So if you are giving the inputs u1 and u2, which results in outputs of y1 and y2, then the summation of the same inputs, if it is given as an input, will get the output to be the addition of the individual outputs. And if we are multiplying with the scalar and giving the input, then the output will be multiplied by the same scalar. So that is what we essentially checked here. We gave the input A into u1 t plus B into u2 t, and after plugging it in, we were able to verify that the output y of t corresponding to that input indeed is the linear combination of y1 of t and y2 of t, with the coefficients being A and B. This means that this particular system is a linear system. So coming at the second question, a spring mass damper system is governed by this equation. So we have been asked whether the system is linear or not. Okay. So here uh, we can see first of all the coefficients of x double dot, x dot, and x and u are not all constants. For the coefficient of x dot is essentially, yeah, so the coefficient of x dot is uh, not linear, it is x of t. So if we have learned in the class, we know that a linear system has a governing equation which is a linear ODE with a constant coefficients. So uh, alright, okay, sorry for my interruptions. Spring mass damper system is governed by this equation. We have to check whether this is linear or not. So so the f of t is the input term and x dot of t is the output term. Let us try to go by the same argument. So we will give uh, okay. So let us see if, what happens if we consider a linear solution. So x of t equals to this. So all right, there is one simple way to prove this. Okay, so a simple way to prove whether this is linear or not, we can see whether the system is non-linear. So in this particular way of thinking, we can just uh, yes. So in this particular system way of thinking, we just need one argument to prove that it is a non-linear system. So let's write it this way. So I am just replacing x by c into x. C into x dot of t plus c into x is equal to c into f of x. So cx double dot on simplifying plus c square into x of t into x dot of t plus c into x. This is what we are getting here, c into f of x. But if the system was linear, we would not see any coefficient coming up in this way. This is not equal to c into x double dot of t plus c of x of t into x dot of t plus c of x. So with this similar argument discussed here, if we are having a into u of t as the input, we will get a into y of y of t as the output. Our output ideally should have been this when we give the input of c into x. However, it is not that. So the linearity of this system cannot be said. Coming to this, the next question, the complex function 1 upon s square plus 2s plus 1, is it where this question is singular at? So uh, so uh, when is a complex function singular? When the roots of the denominator polynomial, sorry, when the denominator polynomial is 0, the complex function becomes singular. So s square plus 2s plus 1 should be 0. This is essentially s plus 1 whole square equal to 0. So we have two repeating roots at s is equals to minus 1. So when s equals to minus 1, this complex function is essentially 0. Coming to the next question, calculate the Laplace transform of e power t into sine of 2t. So first of all, what is the Laplace transform of sine of 2t? The Laplace transform of sine of 2t is 2 divided by s square plus 2, and the Laplace transform of e power t.
So isn't it s square plus 4 square? I mean 2 square. So it should be s
Yeah,
square
yeah.
plus 4.
Oh, I'm so sorry for that. It's my first class, and I'm trying to look at multiple sources and admit people. Yeah, thank you for pointing that out. So L of so the Laplace transform of e power. Uh, okay, so let's go with the formulas. The Laplace transform of e power minus at is uh, oh yeah. So when we are taking the Laplace of e power t term, it essentially means substitute. When we are taking the Laplace transform of a term which is multiplied by exponent, say e power minus at, then what we do is we change the complex variable from s to s plus a. So here the value of a is minus 1. So s, which is the complex variable, will get yeah, it's positive, right? So the complex variable will get multiplied by s minus 1. Sorry, the complex variable s will get replaced by s plus 1. So L of e power t into sine of 2t is equals to 2 divided by s minus 1 whole square plus 4, which is s square minus 2s plus 5. Uh, Now coming to the next question, we have been given that y double dot of t plus 3 into y dot of t plus 4 into y of t is equals to u of t. So let me make a correction here. It's u of t. So taking the initial conditions to be 0, that means y of 0 is 0, y dot of 0 is 0, and y double dot of 0 is 0. So
And the equation you wrote minus 4y of t, sir.
I,
You've written plus over there.
okay, thank you. So right, minus 4y of t with the 0 initial condition. So we want to provide a unit step input to this system, and then we want to see how it responds. So when we are taking unit step, that is u of t equals to 1, when we are taking this as a unit step response, the Laplace transform corresponding to u of t equals to 1, which is u of s, is 1 by s. So taking the Laplace transform of taking the Laplace transform of this equation and taking initial condition to be 0, we can write s square y of t, y of s, plus 3 into s into y of can you scroll to question 2 real quick? Okay. I think my logic was not very clear here. Shall we cycle back to it at later time? Yeah, I acknowledge that's not very well explained.
Okay, sir.
All right. So
Okay, sir.
yeah, these notes will be shared with you. I will make the necessary corrections wherever it is. Okay. So continuing with the Laplace transform, uh, y of s minus 4 into y of s is equals to u of s. So if I were to write y of s is equals to, so I'll take the y of s term common. So we'll have the quadratic term s square, the linear term here as 3 into s minus 4 as the constant. Into u of s. So since we are taking unit step response, we'll substitute u of s is equals to minus 1 by s, and we'll also just so s square plus 3 minus 4. So we can write s plus 4 and s minus 1. So that will give us plus 3 and minus 4. And we have 1 upon s from the unit step response. So if we write the terms into s minus 1 into 1 upon s plus 4, these are the three factors of this polynomial. So now if we take inverse Laplace transform, okay, so taking inverse Laplace transform, just give me 1 second. Uh, the Laplace transform will be inverse Laplace transform uh, for the form y of s equals to a by s plus b into let's say s plus 4 plus c into s minus 1. We'll just cross multiply these terms and come up with an expression. Then we'll compare the terms. So in the numerator, we can have this a into s plus a into 4 plus s into b divided by s plus 4 into s plus c divided by s minus 1. So let's cross multiply this again. A into s plus 4 into a plus b into s plus b into s plus s square c into s square plus c into 4 in bracket s minus 1 divided by the denominator. So let's just multiply this numerator term. A into s square plus 4 into a into s plus b into s square minus a into s minus b into s minus 4 into a plus c s square plus 4 into c. Sorry. Oh. Mm, oh, I think I didn't complete this multiplication, right? Yeah, C4S, correct. So ABC into S square plus 4 into A minus A minus B minus 4 into C S uh, minus 4A. Is that correct? Right. So now comparing the coefficients here, sorry,
Sir, plus 4C.
plus 4C.
Sir, in the 4A minus A minus B minus 4C, it should be plus 4C. Okay?
Oh, okay, plus 4C there. All right, thanks. So, all right. So, comparing the coefficients here, we only have a constant term. Everything else is 0. So, the quadratic term, S square term, is A plus B plus C. This has to be 0. The S coefficient, S power 1, is 3A minus B plus 4C equals 0, and S power 0 term, which is minus 4A, which is 1. So this implies A will be minus 1 by 4. So A is minus 1 by 4. Then we can substitute back that value of A in above two equations. Let's quickly do that. B plus C is equals to 1 by 4, and minus B plus 4C is equals to 3 by 4. So if we add these two equations, the B term will get cancelled. We will have 5C equals to 1. So C will be 1 upon 5. So if we plug in C equals to 1 by 5 in any of the equation, so B is equals to 1 by 4 minus 1 by 5. That will be 1 by 20. So we have values of A, B, and C. We can write y of s is equals to A by s, so that is minus 1 by 4s plus B by s plus 4. So B by s plus 4 is 1 upon 5 in bracket s plus 4, and plus C, that is 1 upon 5 in bracket s minus 1. So now if we take inverse Laplace transform, uh, y of s will become y of t. The constant term would be the same. Oh, sorry, this is B is 1 by 20. Right. So 1 by 20 e power minus 4 into t plus 1 by 5 e power, this is positive t. So now if we look at what we have been asked, what is the value of output as time tends to infinity? So as t tends to infinity, y of t, since there is this e power t term, this will drive your output y to infinity. So y of t will tend to infinity. Next is the coefficient of e power t in the output function. So the e power t term has coefficient c, that is 1 by 5. So this is a part, this is b part. C part is coefficient of e power minus 4t in the output term. So C, that the coefficient is 1 by 20. And D portion, we are asking, is the output bounded in magnitude for all time? So even if when we are giving a unit step input, this e power t term will keep growing towards infinity, and hence y of t will also go towards infinity. So this term is not bounded. So let us yeah, so that ends today's tutorial. So I know the question 2 has not been explained properly. What I'm going to do for that is we are going to upload the solutions as well as the link of this video on YouTube. So at the I will upload one more small YouTube video which will explain the question number 2 properly. It will be around 2 to 3 minutes. Other than that, we can have any questions from you all now. The YouTube video link will be admit. The YouTube video link will be shared by NPTEL team. I think I can paste the link here. Just give me 1 minute for that. Yeah, so I will try to give link for this channel if possible. So yes, you can ask me. Yes, you have raised your hand. You can ask your question.
Sir, can I ask a question?
Yes, please go ahead.
Sir, in question number 5, sir, in last part option D,
Okay.
sir, I can't get the how can we say that the function is not bounded.
Function is not bounded. You want to know whether it is bounded or not bounded? Can you clarify?
So no, sir, I can't understand the process.
Oh, what do you mean by bounded?
the output must be bounded, sir.
Yes. So let us think of in terms of physical systems. Okay, you have uh, say you have a battery. It has only finite amount of voltage. Your voltage will not exceed that, right? So the output of the battery, which is voltage and current, will be bounded by a physical limit on the system, right? So these equations, as we have seen here, it's a second order ordinary differential equation with constant coefficient. So it represents a second order system, okay, which okay, so there are certain systems that can be termed as unstable systems. For example, you take one tank and you open a tap in it. So after some time, the water will start overflowing. That means that the system is unstable. There is no value to reach per se, mathematically speaking. Of course, there are physical limits that the tank's volume will get fulfilled. Uh, but that can also, if you derive equations for that same thing, you will end up getting a first order system, uh, which is integrated. So in future classes, we will be looking at uh, yeah, so in future class you will learn more about boundedness and bounded input, bounded output stability.
Thank you, sir.
Yeah, so in one line though, output bounded means there is a cap on the output, it will not go beyond it. So we have one question here. Can you explain the difference between forced response and natural response? How can one determine from the final response? So uh, the response of the system, when you are giving an external input to the system, that would be called as a forced response, because you are providing in some energy. In this particular example 5, we are giving a unit step input. So that would lead to a forced response. When the forced response is when you are giving the input to the system, which is non-zero. The natural response of the system, on the other hand, is the trajectory or the values, subsequent values, your output variable y of t in this case would take when you are not giving any kind of input. So when your input is 0, you are not providing any input.